using big force in exchange of a short distance. Okay? Finally, we look at something violent. We are going to break some object. When you are trying to break this stick, you are usually doing this. You don't do this. Because to break the stick, what you need is torque, not force. You need to apply force here to rotate both parts of the rod in opposite direction. That's how you break the rod. To break the rod, here's the rod. You put your knee here, which is going to be the pivot for rotation. And what you want is the left side of the rod to rotate counterclockwise, but the right side, the right part of the rod rotates clockwise, and then you break the rod. So breaking something is actually doing rotation. The force between the rod particles will try to bind the two parts of the rod together, because that's what rod particles do. So if you just look at the left part of the rod as our system, when you apply the force here, there's this lever arm that you have. This is force hand, lever arm of your hand, force from your hand. And this torque is in clockwise or counterclockwise? Counterclockwise. Good. And now, if you try to break it, there used to be attractive force between the rod particles, so the rod can stay as a whole rod. So the rod particle from the right hand side will try to pull with a force in order to stop you from breaking the rod. But the lever arm of the rod is shorter. So of course there's going to be force on every part of the rod, but the longest the lever arm they can get is this long. So the rod will try to resist by applying a clockwise torque, and you try to break it by applying a counterclockwise torque. The force from the rod only have this long of lever arm, and if you go far, you can break the rod more easily. It is the torque that breaks the rod, not the force, because if you apply force right here, no matter how hard you apply the force, the rod will not break before you push it into your knee. It's not going to break the rod. You need to apply torque to rotate the rod. That's how you break it. Okay? Okay? So you can see this kind of, so the reason or the fact that torque is the thing breaking stuff is very important and applied to your construction building. When you are looking at a building, you will see this type of triangular structure a lot. Right. So if you look at the projector, the screen here, the screen is held by a frame with triangle. It is not held by a rectangle frame. So when you have a rectangle frame, the frame will have 4 joints to rotate. So it can actually rotate this way. You can rotate down like this. Can you see that? So to prevent the frame from collapsing, the force between the rod, the force between two rods of a joint will try to push each other. But when they are pushing, the lever arm is really small because that's how big a joint is. They don't have a big lever arm to fight the gravity from preventing the structure to collapse. So this is a bad design. If you do triangle, there's only 3 joints to rotate. In fact, it cannot rotate because you need to break the entire rod in order to rotate. So in this case, the rod is fighting the rotation with this directional force, and you will have a long lever arm. So that's why you see a triangle over there. Even though you're using less piece of material, that's actually stronger. Let me try to show you a picture. Evolution somewhat learned that torque is important in their own way. So if you ever take a close look at the cross section of a tree branch, you'll see it is elongated vertically. Of course, not all the tree, not all the branch look like this, but there are advantages of having a tree branch like this. You see that if the tree branch is elongated vertically, you can have a longer lever arm for the tree branch itself to prevent it from breaking apart. So that's why if you look at some tree branch, you'll see it is elongated in a vertical direction. So when gravity wants to break the tree branch, the branch itself will have a longer lever arm to fight the rotation and prevent itself from breaking. Understand that? That's in your homework. You sure? Okay. Okay. Good. All right. That's it. Good. All right. So that's torque. Do you guys care about center-pivot irrigation? Is that a thing you know? Are you guys agriculture major? No? No? You are? Alright, I mean we need, alright, so that's something we're going to talk about later. So now we learn to start rotation. What you need is torque. Torque is what governs rotation. Force governs translational motion, but for rotation you need